Well, hey everyone, and welcome to another Unity series tutorial. This one is going to be on the A-star algorithm. So what is the A-star algorithm? The A-star algorithm is a pathfinding algorithm that can be used to find the distance, to find the shortest distance path between 2 points. So if you're playing a real-time strategy game and you left click on a unit, you want to send him to go and walk somewhere, and you right click and he'll begin to walk, he needs a path that he can follow and be able to walk around objects that don't need to be walked through or have unwalkable terrain. And the pathfinding algorithm is one of the many ways we can generate an algorithm, a path, give that path to the unit, and the unit can walk down that path. So that's what we're going to do in this tutorial. We're going to build a grid, and we'll basically have an object that will walk from the beginning of the path to the end of the path based on our clicks in the screen. So what we're going to do is, in this first video, I'm going to go ahead and just create the node and the tile behavior scripts that are going to do that, and we will go from there. So as you can see, I created a sprites folder and a scene scripts folder. So in the scripts folder, I created a node script. So we can go ahead and double click and open up the node script. This is not going to be a mono behavior, so we can take that out. Alright, take that out. We'll save it. And then we'll go ahead and get started in filling out this class. So this class is just going to be basically just a bunch of data. And first of all, we're going to start with private read-only list of nodes. And we're going to call it neighbors. It's set to a new list of nodes. So basically each node is going to have a list of neighbors that are neighboring it. How do we go about that? Well, if you look at it like this, let's say we're looking at a grid. That's a 3x3 grid. Okay? And you have a node that's in the middle. And this is your current node we're analyzing, and he has all these neighbors. That's what this list is. It's just a way for us to parse through those neighbors. So, and then now we're going to go into the next. We're going to have a private int x value for the position and a y value for its x and y position. We're going to have a private bool walkable. Is this able to be walked upon or not? And then we're going to have private int gcost variable and an hcost variable. I'm going to get into all that whenever we start talking about the algorithm, but for now, this is the data that we're going to need. So we'll just leave it at that. Now we're going to go and create a private reference to a node that's going to be its parent. Every node will have a parent. We're going to use that to track back up the parents in the final list of nodes to get from the last node to the start node. So that's the path the unit is going to be able to use. Now that we got all our private variables, we need to go and let's start with a constructor. Int x position, int y position, bool walkable. And then now we're going to do this dot x is set to x position, this dot y is set to y position, and then this dot walkable is set to is walkable. Okay, so that'll be our constructor. Now we're going to go and make the properties real quick to access these variables. So we'll do, there's a lot of ways you can do it. I prefer to make my variables private and then publicly access them through properties. You can do auto properties if you like. I just prefer to do it this way. Public int x position. Then this will get return this dot x. And then we'll do a set. And this will return this dot this dot x is set to the value passed. So we'll do this for the x position. We're going to need one for the y position. So we'll go into here and we'll change the X to the Y position. And then this is going to be Y. And this will be Y. Okay, so that's the X and the Y position. We need one for a Boolean value for our, and then we'll call it, is walkable. We're going to return this dot walkable. Oh, I spelled walkable wrong. Here, L. Okay. Oh yeah. So walk label. Wow. There we go. Walkable. It's gonna get right at some point. Okay. So walkable. Okay. Now we're gonna need one. Since we got the walkable, we'll need two more. Okay. We'll need one for the H cost, and then one for the cost. Okay. And what we're going to return here, you guessed it, our H cost. And right here will be the G cost. And then right here is going to be the G cost. Here we're going to have one for the F cost, which I'm going to get into detail when we start doing the algorithm. So bear with me for now. This one's going to be a public int F cost. And all that this is going to do is just return this dot G cost plus this dot H cost. That's all this one's going to do. It's just going to return the cost back. It's just going to return the addition of those two. We'll need one for called parent. It return this dot parent. Oh, I keep getting it backwards. I'm so used to just doing the variables. I'm forgetting properties. You do them in here. Set, and then this dot parent is set to value. Alright, now we're done with that class. We can go and get into our tile behavior. Pull that up. Okay. That, come over here, go back into Unity. Let that compile in the bottom. Oh, node does not contain a, what do we break? Of course. L, and then take off A here. Walkable. There we go. Back up. Wait for it to compile. Awesome. Now let's go ahead and create a tile behavior script. And why am I calling it tile behavior instead of maybe node behavior? It's naming convention. I know I'm going to be using this as a component in the screen for the tiles, because I reference them as tiles, not nodes, but I like the way node sounds. Because you could take the A-star algorithm we write in this node class, and you can take it completely out of your Unity project and use it in any other C# project if you want. And it might be a node in that project. It might not be a tile. So I'm just naming this one a tile specifically for this Unity project because I know I'm going to be putting this on our tile prefabs. So we'll come back into Visual Studio, open up tile behavior. Tile behavior will be a model behavior. We're not going to need the update. We're not going to need that. Come into here. Alone. Come into the tile behavior script. And what are we going to need in our tile behavior script? Well, we're going to need a private reference to a node, which this is going to be the node this tile represents visually in the scene. And then we'll go ahead and access it like this. Node. And yes, this is going to be another property. So what we're going to do is get node. That, and then we'll go ahead and set it to this dot. Node is set to value. Alright, so that is set up. And now in the start function. So what's going to happen whenever we use this inside the code? Well, what's going to happen is we're going to check to see if this dot node is not walkable. That's what the little exclamation point in the front is for. It's to say, hey, is this node not walkable? And if it's not walkable, what we're going to do is we're going to say the game object that has this tile behavior attached to it. I want you to get its component of a sprite renderer. I want you to grab the material on it, its color property, and I want you to set it to color dot blue. So any game object that's a tile that has this script, when it starts, if it's not a walkable node or a walkable tile, it's just going to set it to blue. So that's how we can visually see that this isn't what it's going to look like. We know we can't walk there. And that's it for the tile behavior class. What we'll do now is, now that we got the node set up and the tile behavior set up, we're going to go into sprites while that compiles. I'm going to go and drag in the sprites folder. You guys, if you downloaded the project, you'll have it there. Or anything that you want, you can come into here, set the A-star tile. The texture type is going to be a sprite. It's going to be a single text sprite mode. It's going to be 64 pixels. We'll keep all that good. Clamps font, bilinear is no filter. The max size is actually 64. And we'll scroll down, change normal quality to none. Apply. And now we got ourselves a tile. And what we're going to do is, we're going to go and take this tile, we'll drag it into the scene. Okay, so now we got a tile in the screen, as you can see. And what we're going to do is we'll attach a tile behavior component to it. It doesn't exist. Exists here. Okay, so we'll do that. This, we can rename it to tile. We know it's an A-star tile, so we can do this. We'll rename it to tile. Come into here. We're going to go and create a prefabs folder. And we're going to open it. And we're going to take the tile, drag it in here. So now our tile has a sprite renderer transformed into the tile behavior component. Now we can delete it from the scene, save the scene, and then we can go ahead and end the video here. In the next video, I'm going to take all of this, and we're going to go and actually build out the grid so we can get these tiles displaying and show you exactly how walkable and not walkable shows the different style of tiles and how it interacts from data versus the visuals. So I'm going to get that to you in the next video. Thank y'all for sticking around. Hope to see y'all in the next one. Appreciate it. Later.